All right, guys, today we got 11.5 here. We're going to add and subtract rational expressions. So think back to middle school when we were adding or subtracting fractions, we had to always have a common denominator. So for example, if I want to add a half onto 2/3, our common denominator would be some type of number that um, both of these denominators could divide into here. So the common denominator here in this case would be 6. 2 can go into 6, and 3 can go into 6. And what we typically want to do is look for the lowest or the smallest common denominator. So I think they call it the least common denominator here. So they're going to ask us to do that on a few of these problems here. So anyways, once you have your common denominator, you are going to figure out how to make your new denominators of your fraction look like the common denominator. So like with this first fraction here, if we want to make it look like a 6, we multiply the top and bottom by 3. That gives us 3/6. And then with the other one here, we're going to multiply top and bottom by 2. That would get us 4/6. And then if you were adding these here, I forgot to put a plus on there, but if you're adding your fractions, that would add up to 7/6, like that right there. And that is how you add fractions. So we're going to do that same exact thing here with the rational expressions that we're dealing with here. So like on this first example here, we got 4x or 4 over 2x plus 3 over 2x. So we'll just add up 4 plus 3 since we already have your common denominator. So that'd be 7. And then the denominator doesn't change. It's just going to be 7 over 2x, and that is it there. So let's look at a few of these other ones. Now with these rational expressions, I'm going to get you guys in the habit of changing this middle sign to a plus, but if we do that, we have to change this 3 to a negative there. And you don't have to worry about putting the negative in the top and bottom. You either put it in the top or you put it in the bottom. Typically, I'll put it in the top, up there in the numerator. So anyways, when you combine these up here, the denominator is x plus 4, but when you combine it, it'll be x and then minus 3, and you can't really do anything as far as simplify. Be careful, there's implied parentheses around the numerator and denominator, so you can't say that the x's cancel out because you got the parentheses. So be kind of careful there on those. Okay, next example here. Looks like these are both x minus 2 here, so that's good. So we can add these up here. 3x plus x would be 4x, and that's it right there on that one. So as far as stating restrictions on the domain, it's kind of works like on the 11.4 lesson. You just got to figure out what denominator or what would make the denominator 0. So I guess for this first one here, if we plugged in 0 for x, that would make the denominator 0. So we want to say x cannot be 0. All right, same idea here with this one. You set the denominator x plus 4 equal to 0, just like yesterday's lesson, and then that means x cannot equal negative 4. And then for this last one, I guess we're going to say x cannot equal 2. Okay, so that's a little recap there. Next part of our lesson here is we're going to figure out what the least common denominator is. So like what number or what expression can both of these denominators here go into. Sometimes if you don't know where to start, sometimes it's going to be just the product of your two numbers right there. So the product of x and 5 is just 5x. So that's your least common denominator. And I'm going to abbreviate it with LCD. So 5x is that right there. Okay. Next one here, when you got binomials here, notice that you got x plus 2 and x minus 1, your LCD, or your least common denominator. That's going to be the product of both of those there, x plus 2 and then x minus 1. Just like that right there. Okay, next one here. This one's kind of a special one here. With these, typically you'll want to factor as much as you can. So that x squared minus 4, we can actually factor that. That's a difference of squares. So I'm going to go ahead and just factor that real quick. You can write that as x minus 2 and the x plus 2. Okay, now notice this other denominator already has the x minus 2 accounted for, so I don't have to write that twice. And I guess what you could say that it's missing is it's missing the x plus 2. So this is actually your least common denominator. So you're going to say your LCD is x minus 2, and then x plus 2. It's the combination of everything in all of your denominators. That might be a good way to put it there. But anyways, make sure on these that you always factor if possible. All right, next one here is another one here where we need to factor this denominator here. As far as what multiplies to -3 and adds to 2, I guess we could go +3 and I guess a -1 right there. That would be your new denominator. And you already got x minus 1 over there, so you don't need to write it twice. LCD in this case, x plus 3, x minus 1. It's what, basically a combination of everything in the denominators. Okay, very rarely, but sometimes we'll get problems with 3 different things here. And since all of these here are just completely different types of things here, you got a binomial here, you got a monomial and another monomial, which are totally different here. It's just a combination of all these. So that you'd say the LCD in this case would be 2x times 3 and then times x plus 3. And actually, sometimes we might go simplify this here if you want to multiply the 2x and the 3. Some people might even put 6x and then x plus 3. You don't necessarily need to with the way I'm going to show you how to solve them here in a minute. So either one of these here, technically they're the same. I guess you could even get real fancy and distribute the 6x to the x plus 3, but typically we won't do that. But there you go. Okay, let's see what's going on with this one. This is already factored over here. X squared minus 1. We can factor that to x plus 1 and x minus 1. And then I got this 4. This one's kind of a weird one here. So you already got the x minus 1 accounted for right there. So we got x minus 1 and x plus 1, obviously, for part of your LCD. Whoops. Then you got that 4 as well. But since you have a 2 right here, 2 actually already goes into 4. So you don't have to write 2 again. But you do have to, write the x. So we're going to write 4, and then x plus 1, x minus 1, and then I guess an additional x right there. And that'll be it there. And that's, once again, you don't write the 2 because the 2 already divides into the 4. It's like it's already accounted for on that problem there. So anyways, that's kind of a weird one right there. So be on the lookout. I think we'll see one where we'll actually add here in just a second. So down here, using the least common denominator, we're going to use that to help ourselves add these fractions. Right? And some people skip the step of writing out the LCD, but I'm going to do that for each example here just so you can see what we're trying to get the denominators to look like. So in this case here, notice that you get 3x and 2x squared. Those are both monomials. I need to think of a number that basically 3x can divide into evenly and 2x squared can divide into evenly, I guess. And that's actually going to be 6x squared. So 3 and 2 will go into 6. That's the smallest number there. And then this one has got an x and this one's got an x squared, so they both need an x squared eventually in the denominators to eventually add. So we're going to make these new denominators look like 6x squared in the bottom. That's what we want them to look like. So kind of like that very first problem that we did, like a middle school adding fractions problems, you get the common denominator by multiplying whatever is, or multiplying by whatever is not in that denominator. That kind of sounded weird there, but really what you got to do here, take this first fraction, to make it look like 6x squared, I'm going to multiply top and bottom by 2x. 2x and 2x, just like that right there. 2x on the top, that's going to be 4x, and then 2x times the bottom should get us 6x squared. Now we're going to use that same idea over here on this next fraction here. You got 2x squared. We need it to look like 6x squared, so the only thing we need to multiply by is 3. Okay, once we do that, 3 times 3, that should be 9. And then now we can combine our numerators up. This will be 4x plus 9, and then all over 6x squared, that common denominator. And that's it right there. As far as restricted domain values, you cannot have x equals 0 in this case. And that is it there in the denominator. So, a little weird at first here. Let's try out another one and see if we can get it. So, this one right here, your LCD, least common denominator, is a combination of everything. You got x already accounted for in x squared, so I need something with x squared, and then obviously only got one coefficient, I guess. So we'll do 2x squared there for your common denominator. All right, now since we got three pieces here, we got to be kind of careful. We got a lot of things that we need to make look like 2x squared here. So this first one, we're going to multiply top and bottom by x squared. It's going to give me 5x squared, and then obviously over 2x squared. That's got the correct denominator. Okay, next fraction here, we need to multiply. It's got an x, so we need to also multiply by 2x on the top and bottom. And actually, I forgot to emphasize something. Since there's this minus sign here, change this sign right here to a plus, and then put -1 up there. So then when I go back and multiply by 2x, it's actually -1 times 2x, and that's going to give me -2x, and then over, I guess, 2x squared in the bottom. Okay, now with this last fraction here, you already got x squared, so really we just need to multiply top and bottom by 2. So that's going to give me +4, and then I guess 2x squared. And then all you got to do now is just combine up these numerators right here to one single fraction and put it all over 2x squared. And with these two, I would write the numerator in standard form, which means write all your powers in descending order. So I'm going to write it like that. 5x squared minus 2x plus 4, and then you can put it all over 2x squared. Now, sometimes on these problems here, you're actually going to need to see if you can factor the numerator. 5x squared minus 2x plus 4. I guess you could go and try and look for factors that multiply, I guess, to 20 that add up to -2, and there really isn't any. So this is actually simplified as it gets, but sometimes they'll simplify down a little bit more. We might see some here in just a moment, but that is all you got to do there on that problem there. So had a bunch of stuff going on there. So let's do one with some binomials here. So on this one here, your LCD, this is going to be x plus 1 and then x minus 3. It's basically the combination of your two binomials there. It's already been factored for us, so that's really nice. So each fraction is missing one of the pieces of the binomial. This first fraction, we need an x minus 3 over here. So I'm going to multiply top and bottom by x minus 3. Okay, the reason we do top and bottom, by the way, kind of forgot to emphasize this here. X minus 3 over x minus 3, that's technically 1. And we can multiply 1 by anything and it stays the same value. So that makes it to where, I guess the fraction technically doesn't change. It's still numerically the same thing. All right, now with this 3 here, we're going to actually have to distribute it to both pieces of the binomial. So we're going to go 3x and then minus 9 once we distribute. The bottom, we're going to keep factored. Don't actually try to simplify this. Just keep it as x minus 3 and then x plus 1. Okay. Looking over here on the other side here, let me move this. Okay. Looking at the other side here, this second fraction is missing the x plus 1 binomial. So I'm going to write x plus 1, x plus 1. We're going to distribute that 2. That'll be 2x plus 2 up there in the numerator. And then in the denominator, like before, just keep it as x minus 3 and x plus 1. All right, and then since now we have a common denominator, we can combine these up. This will be x minus 3, x plus 1. And then what do we got here? 3x and 2x, that'll combine up to 5x. And then -9 and 2, that'll be -7. Okay. If you could factor the numerator, you would, but we can't factor that any further, so that's all we're going to do there on that. That's fully simplified. By the way, I forgot to do domain restrictions on the last two. Domain restrictions on this here is whatever the common denominator is. So we'll say x cannot be the opposite sides, so 3 and -1. And that's it there on those. Okay, last one that we did, I guess we need to go back and say x cannot be 0. So make sure you go back and add that in. Apologize for forgetting that. All right, next one right here. So obviously, you got only one denominator, so your common denominator is just whatever your one denominator is. It's just x plus 4. And don't forget to write a whole number as a fraction. You can put it over 1. And then we're going to say, okay, the bottom of your fraction, the denominator, is missing x plus 4. So we'll put x plus 4 in the top and bottom. All right, and then we must distribute -3. So be kind of careful with that. You know, if you got a negative times a negative, make sure you're looking out for that. So I'm going to put plus, and then I'm going to put -3x, and then minus 12, like that right there. And then I guess put it all over x plus 4. All right, and then since you have your common denominator now, we'll go ahead and add up the numerators here. I'm going to go ahead and put the x first. I'm going to put -3x, and then I guess you got 6 and -12. I'm going to put out, I guess, -6 right there. Now, with this one here, I noticed the numerator can factor a little bit, so I'm not sure if we're going to be able to cancel anything out. So what I'm going to do is factor out a -3 out of the numerator, and if I do that, I'm going to be left with just x, I guess, plus 2, and then over x plus 4. And since these binomials don't match, they're not the same exact binomial, you actually can't simplify that any further. So actually you can just leave it like this, or technically this is still simplified over here to the left as well. Okay, excluded values. X cannot be -4 in the denominator because of, one of the asymptotes, I guess. But let's pretend if this was a 4 for whatever reason, that's when you could go back and simplify these. And I think the homework associated with this that we have, we'll have a few just like that there. Okay, with this next one here, we're going to go and get our LCD. Our LCD in this case, combination of these two binomials here. Notice we got a minus in between, so I'm going to change that to a plus and change that to a negative right there. -3. LCD is going to be x minus 4 and then x plus 2. Okay, ask yourself what you're missing here. The first fraction is missing that x plus 2. Multiply the top and bottom by x plus 2. Okay, second fraction, that is missing an x minus 4. So we're going to multiply top and bottom by x minus 4 right there. Up in the numerator, we need to distribute the x. That'll be x squared, and then plus 2x. Okay, with the second one here, we distribute -3. That'll be minus 3x, and then plus 12. Okay, and then we can put those over our common denominator. Honestly, sometimes I'll just write this as one big fraction right away, as opposed to two separate fractions. So kind of what I mean by that is, instead of writing this out here, I'll just skip that and I'll just write it once. I'll just kind of make it one big fraction like this right here and just put x minus 4 and x plus 2. Some people will be comfortable skipping that step. If you are, awesome. If not, no big deal. You can just put it together as one fraction eventually. So anyways, once we do all that there, I'm going to combine my numerators and see if anything combines. The 3x and the the 2x and -3x combine up. That'll be x squared minus x, and then plus 12, all up there in the numerator. And then down in the denominator, we're just going to write x plus 2 and x minus 4 once. Okay. And looking at this one, actually, I think the numerator factors a little bit further here. So let's see how that factors. So if we look closely here, you'll get with this one here, multiplies. Actually, you know what? Now looking at it here, I guess the sign's different here. If this was a negative, I think this would be factorable here. There's nothing that multiplies, I guess, to positive 12 and adds a negative x. So this is actually done right here. So at first I thought it was going to be factorable. All we needed to change is that positive right there to be a negative. But anyways, that's fully factored, and you can't do much with that. Excluded values, x cannot be -2, and x cannot be 4. There you go. And then that's simplified right there. Okay, so it's kind of a rinse and repeat type of thing after this here. It's kind of repetitive. So first one here, this is not factored actually. So this denominator, I'm just going to refactor that. I'm going to write that as x minus 2 and x plus 2. And, if you don't want to have to rewrite the whole thing, Some teachers will be picky, but I'm just going to kind of scratch that out and put that out. Just make sure it's kind of real tight, especially on these worksheets here. If you don't have a ton of room to work with, that's probably a good way to save some space. So the LCD is actually both of those there, x minus 2 and x plus 2. And notice that your first fraction doesn't have the x minus 2. So that's the only thing that's actually missing. So we'll go x minus 2 on both sides, or I'm sorry, I guess on the top and bottom. And then I guess we'll distribute here. That'll get us 2x squared. And then what's that, minus 4x up there in the numerator. And then I'm going to do that step kind of like what I was talking about. I'm going to skip it here. I'm going to just put plus 7. I'm going to put that all over the denominator here, x minus 2, and then x plus 2. Okay. Next, just to see if this numerator factors, I don't think it does. If you're checking to see if it factors, we need something that multiplies, I guess, to 14 and then adds up to this negative 4 here in the middle. Obviously, 7 and 2 doesn't work out, or negative 7, negative 2 doesn't work out, 114 doesn't work. So not factorable there in this case. So leave your answer just like that. And then solutions are, I'm sorry, what is it? Restricted domain. X cannot be 2 and x cannot be negative 2. And that's it there. All right, a couple more. I think, yeah, these two, and then different type of problem here at the bottom. So notice this one's not factored all the way. We need to factor again. This one's actually got a few that we need to factor. Always factor these. That will make the LCD part a lot easier and a lot smaller. So let's see here. Before we get going on this one here, I'm just going to rewrite, I guess, everything factored. Factor out of 3 on this first binomial. That'll give us y plus 3, I guess. And then let's change this to plus, and that's to negative 3. And then the second binomial, I guess we can pull out a y, and we'd be left with y plus 3. So actually, these are pretty close. They both have y plus 3. So you don't have to put that twice, just put it once for your LCD. And then you also have times 3 and then times y. So it looks like here on this first fraction, we're just missing a y. So I'm going to multiply top and bottom by y. Y times y in the numerator will be y squared. Down in the denominator, I'm just going to write it as 3y and then y plus 3. Okay, second fraction, we are missing the 3. So we're going to multiply top and bottom by 3. That's going to get us negative 9, and then I guess over 3y, and then plus, parentheses plus 3. Then combine your numerators, that's y squared minus 9, and then all over 3y, and then parentheses y plus 3. And then actually this one's actually going to come out kind of what I was hoping one would do here. That numerator up there, that's a difference of squares. So we're going to write that as y minus 3 and y plus 3. And then down in the denominator, 3y and then y plus 3. Okay, and then what's nice here is these actually simplify here, the y plus 3's, and then you're just left with y minus 3 in the numerator, and then 3y in the denominator. So this one cleans up a lot nicer than some of the other problems. And go back and talk about your excluded values. Your excluded values, you go and look here at your original denominators before you simplify it, or if you want to look at this one right here. But right here, y can't be 0. And then right here, this means y cannot be negative 3. Right, and those are your excluded values. And then there's your answer. So there you go, not too bad there on this one. On this next problem here, if I was looking at my notes here correctly, there's a typo on this one. The denominator here wouldn't simplify the way we wanted it to, or the way the problem was designed to. So if you want to go ahead and change this minus right here, change that to a plus, and this should make this problem go a little bit smoother in the way we wanted it to. Okay, so looking here at your two fractions, first of all, see minus, so let's change that to plus and then negative. Down in the denominator on the left, that's going to factor, that's a difference of squares, that's, x minus 3 and x plus 3. Okay. Second fraction here, plus 6 right there. So we got x plus 3 and then x plus 2. So if you go off to the side and you do your least common denominator, you already have x plus 3 addressed in both denominators. And then you have an x plus 2 in one denominator, so we need that in both. And then we also have an x minus 3 in the other denominator. And once again, you'll need both. So this first fraction, you need 3 things. This first fraction, we're missing the x plus 2. So we're going to multiply top and bottom by x plus 2. Okay, and then distribute, clean that up. That's 3x, I guess, plus 6. And then that's going to be all over x plus 2, x minus 3, and then x plus 3. Okay, there's a reason I'm kind of writing it like this here. I'm going to skip that step here where I just make it as one big fraction right away, just so I don't have to write as much. All right, second set right here. Got plus 3 and plus 2. So those are addressed right there, but you're missing the minus 3. So we'll multiply top and bottom by x minus 3. Okay, and then take your negative 4, distribute that. That's going to get us negative 4x and then plus 12. Okay, and then instead of writing 2 separate fractions, I just wrote it as one big fraction right away. And then I'm going to go and combine my numerator up. 3x and then negative x is, or negative 4x is just negative x. And then you got the 6 and the 12. We'll call that 18, I guess, once you add them. And then we'll put that over x plus 2, x minus 3, and then x plus 3. Restricted domain values, that's simplified, by the way. Restricted domain values, x cannot be negative 2, positive 3, and negative 3. That's how you do that problem right there. And that's about as hard as you're going to get on a typical test. So there you go. All right. Last category of problems here is when you have like a rational expression divided by another rational expression. These kind of get a little weird here. So we still want to figure out what the LCD is, but you look at these individually here. So that's not a fraction. We don't have to worry about a denominator. And then that right there is a fraction. We got to look at that denominator, and that denominator has an x. So what we're going to do is multiply this fraction right here. We're going to multiply the 4 by x, and then we're going to multiply this entire denominator by x, which means we actually have to distribute. So the numerator, that part's easy here. That's just 4x. But the denominator, we have to distribute, once again, to both expressions or both pieces of that binomial. X times 2 is 2x. And then if you do x times this right here, that's x divided by x. That's actually going to cancel out. That's going to simplify to 2x plus 1 right there. And that cleans up the fraction. So instead of having fractions inside of fractions now we just got one straight fraction. It's just one rational expression, and then you're good to go. And once again, recapping on that, multiply the top and bottom by x. X times 2 is 2x. X times 1 over x. Essentially, the x's will cancel each other out, and you'll be left with 1. So I think we kind of got the same idea here on number 19. It's a little bit different here. The LCD in this case here is going to be 3 and 2. So the number that 3 and 2 go into, that's 6. And what's different with these problems versus the problems up here is instead of finding your LCD and then making a common denominator, we multiply by the common denominator. So we're going to multiply by that common denominator here. We're going to multiply the top and bottom by 6. So 6 times 2 is going to be 12 up there in the numerator. And then 6 times the fraction x over 3, basically just do 6 divided by 3 and then times it by x, or negative x actually. That'll be negative 2x. So we're going to times 6 in the denominator as well. 6 times 1 is 6. 6 times x over 2, basically do 6 divided by 2, and then times that by X, that'll be 6 divided by 2 is 3, and then that'll be, I guess, 3x right there. Now, I'm not sure, something might cancel out here. I'm looking at both of these. The numerator, you can actually factor out a 2, actually, and that gives us 6 minus x. And then also in the denominator, you can factor out a 3, and then that gets us, I guess, 2 plus x right there. And nothing actually wound up canceling out, but now that we have this here, I mean, either one of these is simplified. So we can write our answers like that right there. Okay, 20 is probably as hard as it gets on these types of problems. This one's a little bit wild because the LCD in this case is a combination of these two denominators here. So it's x plus 1 and 2. So we'll put 2 and then x plus 1. And what's hard here is you actually have to distribute both of those pieces. And then to both the top and bottom. So that means 2 and then x plus 1 times that right there, up there in the numerator. So when you do that in the numerator, 2 times 2 is going to be 4. Then you have, I guess, 4 and then x plus 1. And I guess we can go and distribute 4 here in a second to that. Okay, this next one here, when you distribute, the x plus 1s will actually cancel out. And then you're just going to be left with plus 2x. Okay. Now, in the denominator, when you distribute the whole entire thing again, 2 and then times x plus 1, right here, to this first part here, that's just 2 and then x plus 1. Nothing too weird on that one. When you distribute it here to the second thing, the 2's are going to cancel out. And then you're going to be left with minus x and times x plus 1. So, believe it or not, that helped us simplify because now we don't have fractions inside of fractions anymore. That's our technique to get rid of those. Now I'm going to go here and start kind of cleaning some of this up here. I'm going to distribute there. That's 4x plus 4. Then I guess you got plus a 2x. We'll go and combine like terms here in a second. And then distribute 2. That's 2x plus 2. And then negative x times x is x squared, or negative x squared actually. And then minus x in the denominator. All right, next we'll combine like terms up there in the numerator. It looks like we're going to get 6x plus 4. Down in the denominator, when I start to simplify here, I guess we'll get negative x squared. The x's, I guess we'll get, what is that, plus x. And then we'll get plus 2. Now, as far as simplification, I think this is going to be it here. I don't think we're going to be able to cancel anything. This is actually factorable a little bit, but I doubt anything's going to cancel out. Let's see here. So most of the times, just box that out, and that's going to be your answer there. But just to see if it simplifies, I notice in the numerator that we can undistribute a 2 actually, and write this as 3x, I guess, plus 2. In the denominator, what I'm going to do is factor out a negative, and then write this as x squared minus x, and then minus 2. Then that denominator, you can simplify that, or I'm sorry, you can factor that one more step. As far as something that multiplies to negative 2 and then adds to negative 1, you could write x minus 2 and x plus 1. And then I guess with a negative out front. And then up in the numerator, I guess you have 2 and then 3x plus 2. So nothing wound up canceling out, but it had potential to. Like at the very end, like it could have had 2 binomials that could have canceled out. And it didn't work out that way, but sometimes it could. So I guess leave it like this here in blue, or this one here in red right there. Those are technically both right. And that is it here for your lesson today.